Good morning. My name's Avi Miller. I am the Product Management Director for Oracle Linux, which means I cover all of our Oracle Linux versions, flavors, and add-ons, including things like Docker and Kubernetes and Ceph and Gluster and K Splice and dtrace and all those kind of good things. What I'm going to be showing you today is how you can use Oracle Linux to build cloud-native environments, cloud-native applications on-premise, on a developer workstation, move it to your own internal private cloud, move it to the Oracle cloud, move it to someone else's cloud if you really want to, but why would you? Obviously, I'm going to be talking about things that exist now and things that will exist in the future. Before you make any sales decisions, please consult with an Oracle salesperson. I don't mention dates, basically, so I'm not going to sign up to any dates in this presentation, so make sure that you are getting what you pay for, basically. Now, we've been doing this stuff for a while at Oracle. Believe it or not, I went back to my Git history, and I looked for the date that I pushed the first Oracle Linux official images to the Docker hub. So when you do a Docker pull Oracle Linux, you get our stuff. That was done on the 2nd of January, 2016, which is interesting for two things. Obviously, I didn't have a very good New Year's Eve, that I was still pushing stuff on the 2nd of January. And two, it's my anniversary on the 2nd of January, so clearly I was doing things while my partner was asleep. But we have been doing this for a while, and we've been doing it on-premise for a while. We've been shipping the Oracle container runtime for Docker. It used to be called Docker, but they went and trademarked the name Docker, so as of DockerCon 2016, in fact, we started calling ours Oracle Container Runtime for Docker. It is a build using the Moby sources. So it is a fully supported build of a Docker-compatible runtime using the Moby sources. We've been shipping this since about version 07. It's now version 1803, matching the new release cadence for Docker. We've been shipping Oracle Container Services for use with Kubernetes for a while. It's our on-premise build of Kubernetes. Current stable release of that is version 1191, which matches Upstream's 191. We've got a preview build of 110. We have an upcoming preview build of 111 coming out in November. And the next stable release should be 112, hopefully by the end of this year, calendar year, beginning of next year. And we've obviously made a bunch of acquisitions for Oracle Cloud. We acquired Stack Engine and Worker a while ago. Combined, they create something called Oracle Container Pipelines. This is our source control SCM to Docker image workflow system for developers. So it goes from GitHub or GitLab or Bitbucket, one of those sort of source control locations, through Worker, which is our cloud-based CI/CD system, through our container, our managed Kubernetes offering, which is Oracle Container Engine for use with Kubernetes, Oracle Container Engine for Kubernetes, which is our managed Kubernetes, and our Oracle Cloud Infrastructure Registry, which is a private registry per tenant. So we have all of the bits and pieces either on-prem or in the cloud for you to go from source control through CI, through CD, to push to your own container registry and then out into Kubernetes. So let's drill down, and I'm going to be focusing primarily on the on-premise stuff to get to Oracle Cloud. There's enough Oracle Cloud stuff going on today, but I want to work on sort of the developer QA test environments that you're building on-premise. One of the oldest things that we've been supporting is obviously that container runtime for Docker. It's an engine built and maintained by Oracle. Support is included with both basic and premier Oracle support. So if you're a basic support subscriber or a premier support subscriber, you get support for this. We support the full container lifecycle, build, ship, and distribute, all that good stuff. We are, I think, now one of the last remaining Btrfs support vendors. We obviously wrote Btrfs originally, so Btrfs is an Oracle file system. It was developed by Chris Mason when he was still at Oracle. Chris Mason's now at Facebook. Facebook extensively used Btrfs in all their production environments. We still believe it is the best file system for Docker because it's a copy-on-write layered file system, and Docker is a copy-on-write layered container engine. We're doing extensive work with the Docker team to improve and enhance the storage driver for Docker to take more advantage of the copy-on-write nature of Btrfs. We do, however, also support Overlay 2. So Overlay 2 is an alternative using standard file systems to create what appear to be storage layers. There are some really interesting edge cases with Overlay 2. It's not as mature as Btrfs, but it has some fun use cases, particularly with shared storage on XFS, because it utilizes the XFS engine quite nicely. We do require, however, that you use the Unbreakable Enterprise Kernel Release 4 or Release 5 on Oracle Linux 7 for this. We know that other vendors can support Docker up to about version 1.12 on their kernels. We're pushing a Docker version 18.03. We need the support of a modern kernel, particularly UEK5 for the more modern Kubernetes networking stacks for Flannel and Calico. UEK5 is great because it has support for things like VXLAN, Mac VLAN, IPVLAN, all of those sort of modern networking, the networking tools that we need to kind of further isolate that is not supported in the older 3X kernels that other vendors use. We introduced both multi-stage builds in our 17.06 release and now multi-stage builds with ownership maintenance, or maintaining of ownership between builds. You'll notice when I talk about our Docker Docker files on GitHub, we've started to move towards a multi-stage build process for our product images for things like database and WebLogic. So we do the initial install in one layer or in one build, and then we push that install. That is a great way of saving space in the final image. We've supporting now Overlay 2 with SE Linux enabled, and we've added registry list functionality. It's in tech preview in this 18.03 build. What registry lists allow you to do is set up both white and black lists for integrated registries to your Docker client. So for example, in production, you could blacklist the actual Docker hub so that you don't just get random Docker images pulled by someone from the Docker hub. And you could whitelist your own internal registries so that they're the only place that you can pull images from. That way you can control image provenance, and you can control versioning. For example, you could restrict your QA systems to only pull from the QA registry, and your production systems to only pull from the production registry, which makes it quite useful from a environment promotion perspective, to know that your QA systems are only using the images produced in or stored in the QA registries. Moving on, once you've got a couple of containers, you want to orchestrate them. We're now shipping Oracle Container Services for use with Kubernetes. It is a certified Kubernetes build 1.9, which is currently supported. We have a preview of 1.10, which is also certified Kubernetes 1.10. And we are planning to release a 1.11 or 1.12 is a preview release as well. It is designed and used by Oracle internally. It's used on things like the Oracle Cloud Customer Machine. It's used by Oracle Cloud, and you can use it on Oracle Cloud as well. So you can make the choice with a cloud deployment of either using our Oracle Container Engine with the OKE managed Kubernetes, it's included in Oracle Cloud Infrastructure, or you can build your own Kubernetes using Oracle Container Services. The nifty thing about this is that support is included again with Premier support, so you're not paying anything extra for a certified Kubernetes build. We announced yesterday the Oracle Linux Cloud Native environment. This forms the underlying infrastructure for that cloud native environment. What you will find over time, and I'm actually speaking about this in the Theatre 6 down in Moscone South near the booth 120. I'll be talking about the cloud native environment specifically. But we're going to start releasing curated CNCF projects that integrate with Kubernetes. First out, we've got things like Helm, Flannel, Calico, FluentD, Prometheus, and Jenkins X. So taking a couple of positions in the stack, if you like. We've got, obviously, Kubernetes for orchestration. We are going to support Cryo as well as Docker for runtime of the containers. We'll be supporting Prometheus for observability of your stack, FluentD for storage and retention of those observability statistics, Helm for deployment of large-scale applications into Kubernetes, so using Helm charts to actually automate that, Jenkins X for cloud-native CI/CD on Kubernetes. And we've been shipping Flannel as the default networking for our Kubernetes for a while. We're adding Calico as a developer preview, and we'll be adding support for CNI, sort of the container network integration, so that you can sort of plug and play additional networking stacks into it. But I'll talk more about that at that session later on. So if you want to get more details about the cloud native environment, come and find me down in booth 120 later this afternoon. We also provide, and we are the only vendor to provide, container native security with K Splice. For those of you who haven't heard of K Splice, it is Oracle's in-memory patching system for the kernel and specific user space libraries. We've delivered now well over 1.5 million patches with K Splice. It's used to deliver CVEs and data corruption bug fixes without any downtime, with no service interruption. In fact, you don't even have to tell the applications that you're doing it. We patch the kernel and runtime user space in memory. So we've done this, and I have a demo about it. You can come down again to booth 120 to see this in operation. We've been doing this for almost a decade now. The ability to patch in memory is something that differentiates Oracle Linux from all of our other competitors. K Splice patching is automated. K Splice patching can be done. We have a particular customer that started their K Splice journey about 5 years ago. They were doing, every 3 months, they would run a K Splice update in QA. And then they increased that to every month, and they increased that to every week. Then they started getting to the point of every day they were updating QA with K Splice patches. They're now up to mission-critical systems in production are being updated once a week, non-mission critical every day. So they're doing this, and they've had 0 regressions with K Splice in memory. The nifty thing is because containers share the same host kernel, once you K Splice the kernel, all of your containers are instantly protected. So we can do in-memory fixing of CVEs across all containers running on a system in a single run. So these are the building blocks. As I said yesterday, we announced our Oracle Linux Cloud Native environment. On top of this, we're going to start adding things to augment this environment. But I wanted to show you some of the things that we're doing to make your development lives a little bit easier as well as you start building solutions that sit inside a Cloud Native environment. First off, our Oracle products as Docker files. One of the things that I'm most proud of as the open source guy, if you like, at Oracle. This is, where did you go? There we go. So this is our GitHub repository of Docker files. And it's kind of amazing that we've gotten people like the database team, the Java team, the WebLogic team, the SOA team, OBIEE team. There's the Web Center stuff, Coherence, Oracle REST Data Services. All of these, and in fact, the one thing that kind of blows people's minds, if I can find Oracle Database, we have RAC running inside Oracle containers. So you can, in fact, run Oracle RAC. The RAC team, and I've been amazed at what the RAC team have done this, they created a storage server that runs as a container to get the emulated block storage into the RAC storage containers. So they've been doing extensive work. There will be, I'm not going to give you an ETA for this, but the RAC team are working hard on a RAC operator for Kubernetes. So Kubernetes can automatically scale RAC for you in a cloud-native environment. And they're working on Helm charts for RAC as well. So you can auto-deploy, auto-scale, auto-heal RAC in a containerized environment. We already have, by the way, Kubernetes operators for MySQL cluster and WebLogic. So if you have WebLogic clusters, you can use Kubernetes to automatically scale and heal them as well. What's also pretty nifty about the Oracle products as Docker files is that these are, with the single exception of Oracle Database single instance, that's the one thing that differs, but for everything else, if there is a Oracle image on the Oracle Container Registry, which is my next slide, these are the Docker files that were used to build them. So there is no difference between the Docker files that you see on GitHub and the Docker images that we ship as binaries on the Oracle Container Registry, as I said, with one exception, which is the database single instance image. And the reason for that is the database single image predates the GitHub repo. It was built and created by the database team before we even started this. Once they did that, and once we created the Oracle Container Registry, we now have a process where products must publish their Docker files on GitHub first, and then we will publish their images on the Oracle Container Registry. What is the Oracle Container Registry? I hear you all quietly ask. So what we have done is we ship Oracle products as Docker images. We've been shipping Oracle Linux 6 and 7 as an official image for x86 and now ARM for a while, so you can go Docker pull Oracle Linux. That's really nifty. Whoop. There we go. Those Oracle Linux images on the Docker Hub are supported. If you have an Oracle Linux support subscription for a physical box and you create Docker images that use, from Oracle Linux as their base image, we support Oracle Linux inside the image as well at no extra cost. So the physical subscription for the server covers as many instances of Oracle Linux as you can shove on that server. If they're virtual machines, we cover all the VMs. If they're containers, we cover all the containers. It's a great reason to use Oracle Linux as the base layer for a particular container. I have no idea why there we go. There's something weird with the HDMI on my laptop at the moment, and sharing things. It pulls up weird things. We have got a whole bunch of open source images, the OpenJDK, NoSQL, OpenStack images are on there as well. One thing we added last week is Graal. For those of you who have been around Code One and have been to some of the Graal talks here about our new polyglot runtime VM, we do now have a Docker container that contains Graal RC7 and Graal RC8. So if you are really into starting to develop for Graal, doing some polyglot runtime stuff, we have images for you. We also have the Oracle Container Registry. So containerregistry.oracle.com, these are pre-built product images. This is stuff like database and Java and WebLogic and MySQL Enterprise, stuff that requires a license and costs money. What we have is similar to the OTN website used to be. For development and test purposes, you can go to OTN, you can say, I agree to the Oracle terms and conditions, and you can download the software as a tarball. Now you can download the software as a Docker image. You can go Docker pool containerregistry.oracle.com/database/enterprise and get a fully running Enterprise Edition container, which is pretty nifty. And it's certainly a lot faster than having to set all this stuff up yourself. And this is, all along our commitment to moving our products into a sort of a more cloud-native environment. As you can see, those Docker files allow you to build your own images. One of the nice things is a bunch of our products are now certified to run inside a Docker container, in particular WebLogic, Java, and database, but they don't require that you use our images. The product itself is certified, so you can build your own, you can use our Docker files, you can modify our Docker files, you can use our images, you can modify our images, but we will still certify the product. And we also have one of the best development tools in Oracle VM VirtualBox. So one of the nice things is yes, all of this stuff is great. Once I get to the point of having a Kubernetes cluster or having CI/CD systems, but how do I do that as an individual developer? Well, VirtualBox is an open source desktop virtualization product. It allows you to rapidly deploy development environments, and we've done a lot of work with tools like HashiCorp's Vagrant to create environments that are best suited for your work as Oracle developers. So for example, we have been shipping Vagrant boxes for Oracle Linux for a while. We've been shipping Vagrant files for Oracle products. And I've actually got a demo that's going to come up almost right now, in fact. I'm not going to do it live. I have tried this before live. I'm actually going to, unfortunately, show you a recorded version of the demo, but I'll be talking live. But we've got things like a Docker registry or Oracle database or an Oracle Container Services for use with Kubernetes cluster, which is the demo I'm going to show you now. Using Vagrant, using VirtualBox, using Oracle Linux, using all of the tools that are available in production so that you can set the stuff up yourself. So let me go and do this across there. Okay. So this is a demo of setting up a Kubernetes cluster using Oracle VM VirtualBox and using Vagrant. So you can see what I'm going to do is clone the Vagrant boxes repo from GitHub. Git clone. There we go. And one of the things and one of the options inside that Vagrant boxes is Kubernetes. Easy first step, Vagrant up the master. This sets up the first master node of Kubernetes. The way our version of Kubernetes is built is the node you designated master is tainted for workloads, which means it won't run a workload by default. What Vagrant is doing is creating a VirtualBox VM. It's automatically giving it two network interfaces, one internal for communication between the Kubernetes nodes and one external for communication from outside. it automatically sets up that VM. It sets up SSH. It puts in a private public key pair. And now it starts running commands inside the VM. The first one installs Docker Engine. Excuse me. You can see Docker Engine was installed there. And then it installs things like Btrfs, the container Linux, SE Linux policies for containers. We're now going to install, as part of this, it formats one of the second hard drive as Btrfs, mounts it for containers. It's now installing all of the Kubernetes RPMs, and then it stops and says, okay, I have provisioned that VM. I'm going to SSH into that VM. And the reason that it stops here is that the container registry requires a login. I'm just going to tail, by the way, on the right-hand side of this demo, I'm going to tail a log file to show you what happens on the left-hand side. The actual script isn't that verbose. So let's become root, and I'm going to go Vagrant up the scripts, and I'm going to start the Kubernetes setup for the master. What it's going to ask me to do is log into the container registry. You can see the log file. I'm not typing very well there, am I? There we go. It asks me to log into the container registry on the left-hand side. That is so that I can get access to those Docker images. Kubernetes runs as a series of Docker images. Now let's go and look at the log file. This can take a while when it says here, please be patient, because what it's doing is downloading individual Docker images from our container registry. So it checks access to make sure that we can pull those images. I will admit in this demo that I am going to speed up time slightly in the recording. It takes about 20 minutes all up if you've got a fairly slow network connection. These images are not terribly big. But once it actually has access, it will start downloading the images themselves. And the nifty thing about this is if you create your own on-premise Docker registry, you can modify the Vagrant files so that it automatically pulls and sets up the Kubernetes cluster. We only pause and need manual intervention here because the container registry requires login. If you do a pre-step of mirroring all of those Docker images to a local registry, which doesn't require login, excuse me, you can change the Vagrant file and it will automatically set up the master and then automatically set up the workers as well. So you can fully automate the deployment of an n-node Kubernetes cluster, because we do 2 nodes by default in the Vagrant file, but you can do n nodes. You can set up, I think we've tested up to about 100 nodes. And it'll automate that as well, which is fairly nifty. Excuse me. I hope this didn't, no, it's still chugging along. So at this point, you can see there it starts to pull the Kubernetes images themselves. There are about 8 or 9 images that it uses on the master and about 4 or 5 images that it uses on the clients. You can see now that it starts to set up the control plane. So it's copied a whole bunch of services. It started the kubelet service, which starts all the containers themselves. And it's at this point, when it starts to set up the control plane, that I speed up time eventually on the demo itself. One of the nifty things about this is that you can automate it through a CI system. So one of the things that we do for testing Kubernetes is we deploy it over and over again on various things. The other thing you can do, obviously, is build this into something like a developer image for workstations. Then, because Vagrant and VirtualBox are both multi-platform, it doesn't have to be, your laptop doesn't have to run Oracle Linux. That laptop, in fact, is running Mac OS, because I happen to run Mac OS. So you can do this completely on a Mac OS desktop. You can do it on Windows, because Vagrant and VirtualBox both run on Windows as well. So you can drive the creation of a standards-based Kubernetes cluster on any sort of commodity laptop workstation. So here we go. It's at 29% of its deployment, 50%. And what's happening in the background, and in fact, what's even worse, I will admit, this is the log file that I'm tailing. If you were actually on the other screen, it just says, please be patient for a very long time. So I do advise you to check the log file that's been created. The nice thing is that the worker nodes take a lot quicker to instantiate than the master node. They download a lot quicker. They're fewer images, basically, for the worker nodes. We're up to 70%. Once you have got the Kubernetes cluster installed, obviously you can then start deploying any application to it that is supported by Kubernetes. So as of yesterday, as part of our Oracle Linux Cloud Native environment, we pushed our first developer preview of Helm, which is almost like a package manager for Kubernetes, if you like. A whole bunch of products are coming out with Helm charts that describe how to deploy that package on Kubernetes. So you can see there, on the right-hand side, it's now finished. On the left-hand side, it says, right, the master is done. You can exit and start setting up the worker nodes. So what I'm going to do now is vagrant up worker 1. Amazingly, it looks very similar to vagrant up of master because essentially it's creating the same VM. It's creating a VM, it's going to install Docker, it's going to format a file system as Btrfs, it's going to install the Kubernetes RPMs, but then when it stops, instead of setting up another master node, it's going to ask me to set up and automatically join the existing Kubernetes cluster. One of the nice things about having Vagrant is that it knows how to join the cluster already created by master. It does this by sharing the file system between each of the nodes. So there's all the RPMs being installed, there's the Kubernetes RPMs being installed. The other reason, by the way, I don't do this demo live, this laptop only has 8 gigabytes of RAM, and each of these VMs uses 2.5 gigabytes of RAM. And if you do the math, that's more gigabytes of RAM than I have on my traveling laptop. So when I bring up the third worker node, it tends to crash my Mac. So I go into worker 1. I'm waiting for Oracle to give me a 16 gigabyte Mac. That'd be great. And now I do a kube setup of the worker. Again, I have to log into container registry. Again, if you have your local registry, you can bypass the step and automate it. Type in my username and password. Through the magic of demo gods, I'm going to fast forward time slightly here as well. It does pull the image. Checks our access. I thought I'd sped up time way quicker than I actually have. There we go. One of the nice, interesting things about Kubernetes workers is that they will run monitoring of their own pods. You can see now it's finished and it has joined the cluster already. So the worker node is ready and joined the cluster. It's using all the certificates that was created by the master during the master's control plane setup. It has validated all of those certificates. It has set up a control plane. And that worker node is ready. I'm going to set up a second worker node as well. You'll be surprised to find out it's exactly the same as worker 1. So this time I speed up time even faster, I hope. There we go. There should be chimes playing at this point. And then worker 2 is set up as well. What we can now do is log out of worker 2 and go back into the master. The Vagrant file, by the way, sets up the master for remote administration as well. So you can set up kubectl on any machine and communicate with this master. I'm going to go into the master itself and check the status of the Kubernetes cluster that we just created. So let's get cluster info. It is up and running. Let's go and find out our nodes. Now, interestingly, worker 2 has started less than a minute ago. So worker 2 won't actually be ready by the time I check the status of the nodes. Come on, check the status. You know you want to. There we go, get nodes. You'll see that worker 2 is not ready yet. It's been up for 35 seconds at this point. It takes about a minute to a minute and a half for each worker to become ready. I'll come back to that in a second. I look at the kube system that's running. You can see there's a whole bunch of services that we provision automatically. Things like etcd, things like the DNS services. Those are all pre-configured. The flannel networking is in there. Anytime that you see one instance of anything running, it means it's only on the master. Anytime you see 3 instances, it's running on each of the nodes. So you can see there are 3 Flannel instances, 3 proxy instances, but only 1 API server instance, for example, because that's on the master. You can see the kubedns is running 3 of 3. It actually has 3 instances of the same container running. So it does fault tolerance on the DNS. The last thing that I want to show you is the fact that Dashboard is deployed as well as part of this. Now, it takes a while to actually set up Kubernetes there you go, the worker 2 is now running. For role-based access control and security, it takes a long time to set that up. It's easier just to go and grab the token that was created as part of the setup. Now, our documentation does cover this. You grab the token, you go to find the dashboard for Kubernetes, you paste in the token, and it will show you the dashboard. There we go, that's the token. This is not how you do it in production, by the way. You do set up users and groups and role-based access control using one of the many CNCF projects that are available to do this. This is the quick and easy way of getting in using the token that was created. And you can see things, my cluster is up, kube system is up, each of the worker nodes is up. And it is, that demo takes about 10, 15 minutes. The actual time taken is about 25. It is faster if you, of course, copy those images locally. It can be as quick as 5 minutes if you have them on a system internally. It's a pretty nifty way of building development environments. And once that stuff is up and running, you can then connect that to things like the Oracle GitHub repos for Helm charts. We have a Helm chart for MySQL. There are Helm charts for some of our cloud-native products. For example, the one that I love and I've been doing a lot of work with recently is the CNCF registry called Harbor. It was a VMware project, and VMware donated it across to CNCF as a new sandbox registry. I did work with the CoreOS team to bring Oracle Linux scanning into their Claire tool. So VMware Harbor, now CNCF Harbor, I should say, integrates Claire for image scanning and Notary for image signing. So in one package, you get all of those all in one go, which is pretty nice. So that was that demo, deploying a Kubernetes cluster. And once you have that deployed, the things that we are releasing, like Helm, Jenkins X, and the other products for Oracle Linux can then be deployed on that cluster as well for your development purposes. And all of this, so far, included in your standard enterprise Linux support. So when you get premier level support from enterprise, it's 24/7 by default. It is included for any Oracle Linux instance on Oracle Cloud. So if you are playing inside Oracle Cloud and you stand up an Oracle Cloud instance, all of this stuff is included at no extra charge, because we include premier support for Oracle Linux with every Oracle Linux instance. So our Kubernetes, our Docker, K Splice, the other stuff that I haven't even mentioned in this talk, which is things like Ceph and Gluster and dtrace and Spacewalk. There are a whole bunch of things that we add and we provide at no charge for you. That 24/7 support is the default. We don't do less than 24/7 support. We don't do less than 148 countries covered by Oracle support. We don't do less than 35 languages. All of this stuff is eligible for Sev 1 support. Anybody here ever been on an Oracle Sev 1 call? We don't hang up. Like if you phone us with a Sev 1 call, and I've had, sometimes it's quite fun, but most times it's not. But a Sev 1 call, your business is out. We do not hang up the phone. We expect you to have 24/7 coverage because we will be working the problem 24 hours a day as well until you're back online. And we provide that by default. Okay? If you have an issue, we fix it. If it's an issue in our build, we'll fix our build. If it's an issue in the upstream project, we will fix it and push that fix upstream for you. So there's a whole bunch of things that we do. And we work upstream. That's our standard operation for all open source projects at Oracle. Even our kernel, we have the Unbreakable Enterprise kernel. We have 2 kernel development teams. We have the mainline team. They do functionality and efficiency and performance tuning of the kernel. They push and work completely in mainline. Our UEK team then pull those fixes from mainline back into our kernel. So we don't actually develop stuff for our kernel first. We develop for mainline first and then pull back to our kernel. The same thing is what we're doing with all of these projects as well. When we work on Kubernetes, we develop on mainline first and pull it back into ours. So that is our modus operandi for working with open source products. If you want to take this all for a spin, you can go to github.com/oracle/Docker images, or our Vagrant boxes from the Yum server. Oracle Linux is free to download, distribute, and use. You don't have to pay us anything to use it. We give you updates for free. In fact, every download of Oracle Linux is pre-configured to pull updates from yum.oracle.com. The only time you need to pay us is if you want to phone us for support. So you can use it anywhere, everywhere. You can give it to your friends, family, people you like. We have all of our product images on Container Registry. We have the OTN community at Oracle Linux Community. It's quite a really active forum on the Oracle OTN community. Obviously, our GitHub presence is also active as well, so if you have an issue with any of the GitHub images, raise an issue on GitHub. If you want to add an image, we take pull requests. So this is not a one-to-many kind of environment. If you want to fix something, and we've had users and customers and developers fix Docker images, improve them, add new ones. I see we've got a pull request now to add the new XE. We released Oracle Database 18 XE on Monday. We've just had a pull request to add the Docker file for that from one of our users out there. Even our database PM, who would usually do that, who is full of, flat out here at Open World, hasn't had a chance to publish it, so one of our users has done it for him. That's it from me. That gets you from your desktop to the Oracle Cloud. Do you have any questions? How are we doing questions for the live stream? Is there a mic that goes to questions, or should I just repeat the question? Repeat the question. Okay, any questions, folks? No? Oh, at the back? Do we have any Windows images? No, we don't, because we're not legally allowed to redistribute Windows. So we can't distribute an image based on Windows because Microsoft doesn't give us permission to distribute Windows. So all of our images are based on Oracle Linux 7 because we have permission to distribute Oracle Linux 7. Yeah. Any other questions? Yep. Not on Windows containers, because of course we don't build a Windows version of them, but you can run them on Windows using the Linux subsystem. So Docker for Windows has a Linux subsystem. It will then boot those containers on a Linux machine. Or you could do what we did here with Oracle VM VirtualBox. Install VirtualBox on your Windows machine, and then Oracle Linux inside VirtualBox, and then run the containers inside VirtualBox. And that's what we recommend all of our internal staff do when they have Windows laptops or Mac laptops. We don't actually recommend using Docker for Windows or Docker for Mac. They're really nifty products, but they hide a Linux VM under the hood. And there are sometimes some really interesting edge cases with networking and storage with those hidden VMs. We would rather you know that you have a VM in VirtualBox so you control the networking and storage yourself. Yeah. And then run containers inside it. Any other questions? We have about 5 minutes, 10 minutes.
Do you want to talk anything about, like in the first line, your talk was something about Oracle pipeline?
Yeah, so on Oracle Cloud, we have something called Oracle Developer Pipelines. It's a really nifty stack that you work with inside Oracle Cloud. It takes you from your source control, whether it's GitHub, GitLab, Bitbucket. It incorporates the Worker tool, so CI/CD as a service. Worker allows you to define, excuse me, what I'll do is I'll show you, let's just mirror my, I will, so if we go to something like the WebLogic Kubernetes operator, because I know that they have this guy. So this is sitting out on GitHub. They have a worker file. This defines how they pull and where they pull images from. So this in fact uses the Oracle Server JRE sitting on the Docker store as its base image. And we have some usernames and passwords configured inside the worker environment. So if we go to worker.com, login, there is worker. I'll log in on GitHub. I'm an admin, so you're possibly seeing things that you shouldn't see on Worker, but I'm an admin for our Worker instance. So you can see a whole bunch of tools. I was starting to learn stuff on how to build pipelines. That's me. I was building developer images, and I was breaking them on purpose because I was trying to see where I could pull things from. But what we do is we drive, we drive the build of images from GitHub through Worker, and then, which I haven't actually done yet in this demo, we have managed Kubernetes and Oracle Cloud Infrastructure, so our Oracle engine for Kubernetes, and our Oracle Cloud Infrastructure registry. One of the things that Worker can do as part of its pipeline, when it successfully builds an image, it can add that image to your registry in Oracle Cloud, and then it can trigger Kubernetes to either upgrade to this new build or deploy it in QA, run, if you're running Worker as a CD system, so a continuous delivery system, you can do testing. My time is up now, unfortunately, ladies and gentlemen. But yeah, so the container pipelines is what we do on cloud for all the stuff that we've added on premise. Yeah. Thank you very much. If you want to talk to us more, we're in booth 120 down in Moscone South. My product manager for the OpenStack team, Dilip, is down front. We've got Panian from product marketing I see in the room as well. So we're sitting on those demo pods. You can come and see some demos of other stuff that I haven't even started talking about and talk to us about more things as well. Thank you, folks.